In our previous section, we have seen the high-level overview of the VPC. So now let's start with some practical also. So to form a VPC, we must follow an order. Okay. So first of all, the very first step is we need to enable the VPC feature. So if you're already familiar with the Cisco Nexus technology, so in Nexus devices, not all features are by default enabled. Okay, so we need to enable the features. Likewise, in case of VPC also on our Nexus devices, we need to enable the feature. Okay, so let's see the topology that we are going to use in this series. So this is a small topology that we are going to use. So we do have our Nexus 7K, and on the left hand side you can see we have N7K1. On the right hand side we do have the N7K2. So N7K, and between N7K and N7K2 we do have three links: Ethernet 1 by 1 and 1 by 2 on both sides, and also the keep alive link. We'll discuss what exactly is that. We also do have the management zero interface. Okay, so the management zero interface of both Nexus 7K devices are connected to each other, and also they are connected with Ethernet 1 by 1 and 1 by 2. So now let's see a quick configuration of that. Okay, so now let's log into our N7K device. So this is our N7K. So the very first step is to enable the feature. So the command is feature VPC. So now we have enabled the feature, right? So now let's do it on our Nexus 7K2 as well. So the command is feature VPC, because if you do not enable the feature, your VPC is not going to work, right? So for example, if you do a if you try to enable the domain for VPC, okay, it is not taking the command, right? It is showing the invalid command because the feature is not enabled. So first of all, we need to enable the feature, right, into Nexus. So we'll say feature VPC, right? Now let's go back to our slide, and so the second step is to configure the domain ID, right? So let's go back to N7K1. So now we need to configure the domain ID. So the command to configure the domain ID is VPC domain, and then if you do a question mark, so we can use up to 1000 domain IDs. Okay, the number that we can use is from 1 to 1000. So let's say we use the very first number, VPC domain 1. So now our domain is created, right? So let's create the VPC domain also on the second device, on the N7K2 VPC domain 1. What is the second step? The second step, so we have completed two steps: enable feature VPC, feature is enabled. The second one is to configure the domain ID. The third one is the establish the peer keep alive link. So now we need to enable the keep alive link. Okay, so these are Nexus 7K. Okay, so as I discussed that between N7K devices we do have the management zero port. So it's not necessary that we use the management zero port for the peer keep alive link, but now let's say that we are using the management zero interface. Okay, if I do a show CDP neighbor on the N7K1, you can see here the management zero port of both devices are connected, right? So N7K1 management 0 is connected to N7K2 management 0 port, right? If I do a show VRF interfaces, you can see here the management 0 port is into management VRF. Okay, so what I will do is, let's say I will go to interface management 0 port, and let's give some IP address to it. Let's say 172.16.100.1/24. Okay, if I check a show IP VRF interfaces. Sorry, show VRF interfaces. Show IP interface brief VRF management. So now you can see here that the management 0 port is having the IP address 172.16.100.1. Now we need to establish the VPC peer keepalive link. Let's first configure the management 0 port on N7K2 also. So interface management 0, I'll say IP address 172.16.100.2/24. Now do a show VRF interfaces. Here also you can see management 0 port is into management VRF by default. Okay. Now show IP interface brief VRF management. So interface management 0 port is in. Now its line protocol is up, its admin up, and the IP address is 172.16.100.2. Let's also try to ping 172.16.100.1 VRF is management, right? Now you can see that we do have the IP reachability between the two devices. So 172.16.100.1 is the management 0 interface IP of the N7K1. Now we are at N7K2. Okay. Now, according to our steps that we need to follow, now we need to establish the VPC peer keepalive link. So we will go to our domain, VPC domain 1, and the command is, I will type peer keepalive destination. What's the destination IP? It's 172.16.100.2, right? I'll say enter, because this IP address, okay, 172.16.100.2, this is the destination IP of the N7K2 device. So now when I say enter just after this destination IP, it means that it is going to take the management 0 interface or the management VRF by default. And if we do a show an interface management 0, management 0 interface is into VRF management, right? So if we do not specify any source, it means that by default it is going to take the management VRF, and into the management VRF what we do have the management 0 interface. So as a source to form the VPC peer keep alive link with the N7K2 or with this destination, N7K1 is going to use the 172.16.1. So we'll also see another case when we are using other interface than this management 0. Then in that case we need to specify the source. So let's say first of all let's complete this. So if I do a show running configuration VPC, now into the VPC domain we have configured the VPC peer keep alive link, right? Now let's do the same on N7K2 also. So we'll go to VPC domain and we'll say peer keep alive destination. Destination IP is 172.16.100.1. Okay, now the command to check if our VPC peer keep alive link is established or not is show VPC peer keep alive. Okay, now you can see here that what is the status of VPC peer keep alive? Our peer is alive. Okay, send status, it's success, right? Sent on interface, what is the interface that we are using for the peer keep alive link? That is management 0, right? Here also you can see the partner informations or the peer device information. You can see the destination IP is 172.16.100.2. Okay, these keep alive interval, timeout, hold, timeout, that we will discuss when we will study about the VPC failures and all. Okay, so by default, the keep alive UDP port, that is 3200, that we already discussed in our previous lecture as well. Okay, so now our VPC peer keep alive link is established. Okay, so let's see how we can use some another interface for this establishment of the keep alive link. Okay, between N7K1 and N7K2, we are having two interfaces, right? One by one and one by two. Okay, so let's try something like this. So I'll go to interface one by one. I will say no shut. I will say no switch port. Okay, let me give some IP address to it. So 192.68.100.1. Okay, /24. And on other side as well. Oh, sorry, I'm on N7K2. Let's keep the IP schema simple and symmetrical. So we'll give one, I mean 100.2 here. So the IP address 192.168.100.2 instead of 100.1. Okay, /24. And if I go to N7K1 interface Ethernet one by one, no shutdown, no switch port, because it's a layer 2 port, so I'm just making it as a layer 3 port. So now IP address 192.168.100.1, right, /24. Now if I do a show VRF interface, so Ethernet one by one is into which VRF? It's into default VRF, right? And same is the case with N7K2. The interface that we are going to use for the VPC peer keep alive, that is into the VRF default. So now let's try to make the VPC peer keep alive with a normal interface other than the management 0. So if I go to VPC domain and if I say peer keep alive destination, now our destination IP is 192.168.100.2. Now if you use, or if you do not use the source, or if you do not define the VRF here, then your VPC peer keep alive link is not going to come up, because the IP address that you are using, or because you are not using the source and you are not defining the VRF, you just enter after the destination, you just give the IP address and you enter. It means that it is going to use the source IP from the management VRF, and into the management VRF we do have the IP address of 172 something, right? So that is why what we need to do is, after the destination IP we need to mention the VRF. And what is the VRF? VRF is default, right? And what is the source IP? Source IP is 192.168.100.1, because we are at N7K2. So we have mistakenly given 192.168.100.2. So the N7K1 IP is 100.1. So now let's say enter. If I do a show run VPC now you can see the command is overwritten, right? So peer keep alive destination, so the destination IP is 192.168.100.2. So now you can see here that we have given the wrong IP address, right? The destination IP should be 192.168.100.1, and the source IP would be 100.2. Now let's see what will be the effect of that, that if we mistakenly given the wrong IP address. So now I'm at N7K1 and I will say VPC domain 1 and peer keep alive and destination IP is 192.168.100.2. The VRF name is default. What is the source IP? 192.168.100.1, right? Now if we check show VPC peer keep alive, now you can see here the VPC keep alive status is suspended, right? Destination IP not reachable. Now let's go to N7K2. If you check here show VPC peer keep alive, you can see the VPC peer keep alive status is suspended because the destination IP is not reachable, right? Okay, so now we need to correct it, right? If we do a show run VPC, we need to go to VPC domain 1 and we need to say VPC, peer keep alive destination. So the destination IP will be 192.168.100.1 and the VRF is default. Source IP address would be 192.168.100.2, right? Now we can also try to ping 192.168.100.1 using the VRF default. So we are able to reach the peer device Ethernet 1 by 1 IP, right, which is into the default VRF. So now let's check the status. Show VPC peer keep alive. So now you can see the peer is alive, right? So our second step is also completed, right? Or you can say the third step is completed. The first step was to enable the VPC feature. The second step is to enable the VPC domain, or you can say to configure the VPC domain. And the third step was to make your VPC peer keep alive link up, right? Now our VPC peer keep alive link is up. You can see here the peer is alive, right? So there are some points that we need to make sure regarding the VPC peer keep alive link. So that we also discussed in our previous lecture that into the VPC peer keep alive link, the two IP addresses of the two peer devices, there is no condition that they must be into the same subnet. They can be in any subnet. So as long as the two IP addresses are reachable, it works perfectly fine. Okay. Okay, so there are some recommendations for the VPC peer keep alive link. So if you're using the dual-SUP, in that case, it is recommended that we do not connect the management zero interface back to back. Okay, so let's say this is N7K1 and we do have the dual-SUP engine. Okay, so now let's say this is SUP 1. Okay, this is SUP 1 and this is SUP 2. So as we know that if we are using the dual-SUP, so the active SUP is going to own the management zero interface, right? So let's say this is the management zero interface which is connected to our, let's say this is our active SUP and this is our backup SUP. Okay, so because the management zero interface is owned by the active SUP engine, so management zero is back to back connected to the N7K2. Okay, so let's say on management zero interface you have given some IP, let's say 10.1.1.1/24. Here also you have given the IP on the management interface, let's say 10.1.1.2/24, right? So you can see here why it is recommended not to use the management zero interface back-to-back connectivity in case of dual SUP, because in case of active SUP failure, the keep alive connectivity can be broken. Let's say your active SUP is down or it is failed. On your backup soup also we do have the management port, right? Here also you can see we do have the management 0 port. Now the management port, now because the active soup is failed, now supervisor 2 is going to take over. Now this is our active soup, right? Now this will become our active soup, and the management 0 port will be owned by the supervisor 2. So now the IP 10.1.1.1.24, this will be used by supervisor 2 management 0 port. But you can see here there is nothing connected on the management 0 interface, right? So if because this link is down now, soup is down, so this link is down, correct? So now there is no way for N7K2 to reach the supervisor engine 2 management 0 interface, right? And even though let's say you can think of like that, okay, no problem, we'll connect the backup soup engine management port also to the N7K2. But in that case, let's say this was your active soup and this was your backup soup, because the management 0 interface will be owned by the active supervisor engine only. So because now management 0 is active here and management 0 is active here, then it is not going to work, right? So now in that case, what we can do if we are using the dual soup situation, okay, or if we are using dual soup into the Nexus 7K or our Nexus devices. So now let's see what's the solution of that. So this is the solution. So what we can do is we can use a layer 2 switch to connect the management 0 interfaces. Let's say this is the management 0 interface of active soup, and this is the management 0 interface of the backup soup. Same is the case here, management 0 of active, management 0 of the passive. So we'll connect the management 0 interfaces to a layer 2 switch. And now you can imagine a situation that your active soup fails, but still because you do have the layer 2 switch in between, then your other device can reach to the management 0 of another interface or another device, right? Because let's say on the management 0 of N7K, we have given the IP 10.1.1 like in our previous case. And here we have the 10.1.1. Let's say 2/24, and let's say these are the access ports, and let's consider for the sake of argument that these are in VLAN 1. Okay, so all these ports are into VLAN 1, these are also into VLAN 1. So let's say this is the active management 0 interface or the active soup. Here it is the active soup. So now let's consider a situation that your active device is failed, okay, or your active supervisor is down. So this is down now. Now your backup interface or your backup soup is going to take over. Now this IP 10.1.1, it is going to shift to this interface, right, which is the management 0 interface of the backup soup. And your active management 0 interface is as it is on the N7K2. So now when N7K2 needs to talk to N7K1 on this IP, it is going to send the ARP, right? Because it is on VLAN 1. All the interfaces on the layer 2 switch is on VLAN 1. So now this link is down. So layer 2 switch, it is going to send the response on the VLAN 1 on port number 2, let's say here, which is connected to the backup soup. And finally, the backup soup is going to receive the packet which is sent by N7K2. So this is the solution, and this is the recommendation also, that if you are using the dual soup scenario into the VPC, so in that case, do not connect your management port back to back. Okay, so in that case, we can, what we can do is that we can put a layer 2 switch in between, and we connect our management 0 ports to that switch. So in that case, our active supervisor fails and our backup supervisor take over the role of management zero port, then our connectivity will not be broken. Okay, so now we can see here that our three steps are completed. So we have enabled the feature VPC. Second step is to configure the domain ID. Domain ID we have already configured. This third step was to establish the peer keep alive link. So our peer keep alive link is also established. So in our VPC peer keep alive link, we can also do one thing that I forgot to mention, that let's say you have a layer 2 link between your devices and you create some SVIs and you give some IP and then you can give the connectivity. So as I mentioned that for the VPC peer keep alive link, the most important thing is to have the connectivity. If you do have the connectivity, then your VPC peer keep alive link is going to come up no matter how you make them up, be it with the SVIs or with the layer 3 links, or maybe you do have some WAN connection over which you are doing some kind of routing. Okay, so now our next step is to establish the VPC peer keep alive link. Okay, so now let's go back. Okay, so now let's enable our VPC peer link now. If I do a show CDP neighbor, and if I go to our drawing, now we do have the VPC peer link because we are having only two ports on the N7K1 and N7K2. So Ethernet 1 by 1 and 1 by 2. So 1 by 1 we have already used for the VPC peer keep alive. So I'm going to use only one link. Okay. So that is show run interface Ethernet 1 by 2. Show run interface Ethernet 1 by 2. So what I will do is I will go to the interface Ethernet 1 by 2. I will do a switch port. I will do a new shut. Let's make it as a trunk. So switch port mode trunk, and let's put it into a port channel. Let's say channel group 1 mode is active. Now you can see here the message LACP process needs to be started before configuring active or passive mode. So as we discussed earlier also, that in the Cisco Nexus technology, we need to enable the features first, right? So first of all, we need to enable the feature. So I will do a push. So when we do a push, it means that we are saving our position into the CLI. Okay, now I'll show you how. So now I was in the interface mode, right? And now I write push. So I will do a exit. Now I will enable the feature, let's say feature LACP. Now I want to go back to the previous section where I left, because I was in the interface mode where I was enabling the port channel LACP mode, right? So now I will type pop. Now if you when I type pop, I will go back to my previous mode. If I type where, so now you can see we are again back to the interface mode. So this is the use of push and pop. This is how we can use push and pop into the Nexus CLI. Okay, now I will do a channel group 1 mode active. Okay, so now if I do a show run interface Ethernet 1/1 to 2. So 1 by 1 interface we are using as a VPC peer keep alive link. So 1 by 2, now I put it into the LACP mode or LACP active. Now the last command to enable the VPC peer link is I will go to interface port channel 1. I just need to type that it is a peer link. Okay, or VPC peer link. Show run interface port channel 1. So port channel 1 is VPC peer link. So now you can see here that by default, as when we give the command VPC peer link, the port type is changed. Okay, now the port type is network. It means that the bridge assurance is enabled. If you do a show log last, let's say 20. Okay, so I was looking for one log where it will show us that the bridge assurance is enabled. Okay, maybe I will enable the log on the second nexus and then we will see. So what we have done so far is that we have put our ports into port channel 1, and as soon as we type this command VPC Peer Link, the bridge assurance is enabled. Okay, so we will discuss in a separate lesson what exactly is the role of this bridge assurance. So you can understand that when we enable the bridge assurance, mainly it is going to track the links. Okay, just to avoid any unidirectional link, it will keep on sending the BPDUs on all the ports where it is enabled. And if the port miss any hello or sorry, not hello, if the port miss any BPDU, then the port is going to be into bridge assurance inconsistent state. So it is used to identify the unidirectional link, and also it is going to check the VLAN database also. For example, you create any VLAN. Let's say I create a VLAN 10 here on XS7K1 and I do not create VLAN 10 on the N7K2. So it is also going to track the VLANs also. So it is, or you can consider it like as it is going to ping the peer device on a per VLAN basis, and if it doesn't find the VLAN to be created on another device, then that particular VLAN will be pruned or that will be blocked onto the peer link. So this is the feature of bridge assurance. Say logging monitor, logging console. Okay, so now I'm at N7K2. Here also we need to create the peer link. So right now if we do a show VPC, so now you can see here the peer is alive because the VPC peer keep alive link status is up, but the peer is down, right? Because we did not create the peer link on the another side. So I will go to N7K2. I'll say Ethernet 1 by 2. I'll say no shutdown. Switch port. Uh, switch port mode trunk. I'll say channel group 1 mode active. Okay, so here also we need to enable the feature first. So I will do a push. I'll say exit feature LACP. I will do pop to go back to my previous section. Now if I check, so I'm into the interface mode. Now I will type again channel group 1 mode active. If I type a show run interface port channel 1 membership. So into the port channel 1, how many ports we are using? We are using only one port. Okay, so if I do a show port channel summary, so now we can see that our port channel is up. If I do a show VPC now, it is saying that peer link is not configured. Eventually it will come up, it will take some time. Show port channel summary. So port channel is up. Show VPC. It will come up. Let's wait. So I'm pausing the video and I'll resume it once it is back, once the peer link is up. Okay. Actually, we forgot to configure the peer link. If you can see here, what is the peer status on N7K2, you can see that peer link is not configured. So what we can do is, because if you do a show run interface port channel 1, we did not give the command, right? VPC peer link. So this is what I like in the VPC, because it give you a message for everything, right? Because it is clearly mentioning that VPC peer link is not configured. That is why our peer link is not coming up. So what we need to do is, I will do a interface port channel 1. I will say this is a VPC peer link. Now you can see here, as soon as we give this command, it is giving us this message. Please note that the spanning tree port type is changed to the network type, uh, to network port type, right, on the VPC peer link. So because uh, if you check here the output of interface port channel, it was just simple spanning tree mode trunk, right? But now if you check here, show an interface port channel 1, automatically this command is there, spanning tree port type network, because the bridge assurance is enabled. That is why now your port type is changed to network. So now if you check a show VPC, now you can see here the peer status. It is peer adjacency formed, right? Our peer is alive. The configuration consistency status is success. Per VLAN consistency status is success. Type 2 consistency status is success. So we'll also discuss these consistencies. So right now you can see that our peer link is up, and the active VLANs, because we do not have any VLANs configured, that is why there is only one VLAN which is active on the port channel 1 or onto the peer link. Okay. So there are some recommendations for the VPC peer link. So the first point is that the member ports must be of 10G ports. So to form a VPC peer link, the ports must be of 10 gig. Okay, because onto the peer link, the 1G line cards are not supported. Okay, and also the FEX ports. So you can see that in the FEX ports we also do have the 10G modules, but the FEX is not supported. Okay, so we cannot use the FEX links or FEX 10G links to form a VPC peer link. So we just need the 10G ports. Okay, the second point is use at least two 10G ports for the redundancy, right? So it means that if you are forming the VPC peer link, so at least use uh, two links. So just in case your one link goes down, that your peer link will be up, right? So to form the port channel for the VPC peer link, we can use different line cards, and different line cards they support different number of member ports to form a channel. For example, you can see here that if you're using M1 and M2 line cards to form the VPC peer link, then it supports up to 8 member ports. And if you're using F1, F2, F2E, F3 or M3 line cards, then it supports up to 16 member ports. So we can use 16 ports to form a port channel to form the VPC peer link. Use at least two different line cards. So the last point is that use at least two different line cards in case to increase high availability of the VPC peer link. What does it mean is that, let's say this is our N7K1 and this is our 7K2, and you connected both the N7K2s and you formed the port channel. Let's say this is port number 1 by 1, this is port number 1 by 2, and both the ports you are using from the same module or from the same line card. And let's say your line card fails, so in that case your VPC peer link is going to be down. So this is what it is mentioned here, that to achieve the high availability of the peer link, so these two ports or the ports that you are using to form the VPC peer link, they must be from the different line cards. Only then you can achieve the high availability. Just in case your one of the line cards goes down. Okay. There are some unsupported line cards combination for the VPC peer link. Now you can see here that we cannot mix and match the line cards. So you can see the first example here. So on one side we are using the M1 module or M1 line cards. On the another side we are using the F1 line card. So this is not supported. Same is the second example. On one side we are using the M1 line cards. On the second peer device we are using the F2, so this is also not supported. On the third side, or on the third example, you can see on one side we are using the F1 line card, on the second switch we are using the F2 line card, so this is also not supported. So we must use the same line cards on the both side. For example, you can see here the supported line card combination for the VPC peer link. So on both side here in example one, or in the first example, we are using the M1 line cards on both side. Here we are using the M2 line cards. Here we are using the F1. Here we are using the F2 line cards. So there is one, sorry, there is one exception, that on one side we can use F2 line card and on another side we can use the F2E. So this is one exception that we can use to form the VPC peer link. Okay. So what is the logic behind using the same line cards? So because we do have the each port type, they are having the different hardware characteristics, right? In terms of forwarding or maybe queuing and security, they do have the different behavior. So in order to achieve uh, the symmetry between the two devices and to avoid any forwarding plane issues, so we are using the combination of same hardware models and the same line cards to form the VPC peer link. So that is the logic behind using the same line cards to form the VPC peer link. So now our all steps are completed. So the last step now is to form the VPC to the downstream devices. So in our example, let's create a VPC for N5K1. Okay, so I'll go to N7K1. What are the ports that are going to the N5K1? That is Ethernet 1 by 3 to 4. So I'll go to interface Ethernet 1 by 3 by 4. I will do a no shut and I will do a switch port. So before we do this, let's check uh, show VPC. So now if we do a show VPC role, so now you can see here that N7K1 is our secondary switch. Okay, so the as soon as we enable the VPC and VPC peer link is up, you can see here the VPC system MAC, it is automatically created. So the value till here it is reserved by Cisco for the VPC technology, and you can see because we are using the domain ID 1, right? So this is the domain ID number because we are using 1 here, that is it is 01. So automatically this VPC system MAC will be created. So if we go to N7K2 also, if I do a show VPC role, here you can also see that this VPC system MAC is same, right? Because we are using the VPC domain ID 1. So here is one VPC system MAC and there is the VPC local system MAC. Okay, and we do have the VPC peer system MAC. Now you can see here because the VPC local system MAC is, because by default you can see here the VPC system priority that is 327667. This is the default, and the peer device VPC role priority is also same, right? So now you can, now the second criteria that is going to be matched to decide the role of primary and secondary is the MAC address. So the local system MAC is 503.4009.0007, And for the peer device, what is the system MAC? So you can see here we have 09 and here we have 0A. So this is the lower MAC address. That is why N7K2 is our primary device. Okay. So this local system there now we just keep in mind that this VPC system MAC. So the VPC system MAC, as we discussed earlier also, it is derived from the, or you can see here that because we are using the domain ID 1, so in the end it is 01. So when you create the VPC peer link and both your devices are uh, formed a VPC now and decided the roles, so this VPC system MAC is automatically created, and this VPC system MAC both the peer devices are going to use as a LACP ID as well to fool the downstream devices, so that they can look like a single device. Okay. And this local system, like if your peer device, they are connected to some other device, but that is not a part of VPC, in that case they do not need to use the system MAC, right? So for a device which is not in VPC, they do not need to show them as a single device, right? So in that case, they are going to use the local system MAC. And this local system MAC is derived from the VDC, because if I do a show VDC here, show VDC, you can see here 5304009, and you can see here this is the VPC local system MAC. So this VPC local system MAC is derived from the VDC. If I check on N7K1 also, and if I do a show VDC, you can see here 503400A. So the local system MAC is derived from the VDC. So now this is the difference between the local system MAC and the VPC system MAC. So VPC system MAC, peer devices are going to use to fool the downstream device where they have created the VPC. For example, now we'll see the effect of this. So if I go to our diagram, so on N7K, the ports that are going to N5K1 is 1 by 3 and 1 by 4. So I will go to N7K1, uh, interface Ethernet 1 by 3 to 4. I'll say no shut. I'll say switch port. First of all, I will not create the VPC, or I will not put the port channel into VPC, just to show you the effect, or just to show you the use of this VPC system MAC and the local system MAC. So we'll say channel group 2 mode active. Okay. Show run interface port channel 2 membership. So into port channel 2 we do have two ports, 1 by 3 and 1 by 4, and they are a part of trunk. Now I will go to N5K. The N5K ports are 1 by 3 and 1 by 4 as well. I will go to N5K. I will say interface Ethernet 1 by 3 to 4. I will say no shut. Switch port mode trunk, channel group 2 mode active. Okay. Also, what I will do is I'll say interface port channel 2, let's say shut down. On interface 1 by 3 to 4, I will enable LACP rate fast. Okay. LACP rate fast. What does it mean is that first of all we need to shut down the port. I will use the LACP rate fast. So what is the meaning of this command? So by default, on the let's say if we have two devices into the LACP, let me quickly draw something. So let's say we have two devices. Here we have one switch. Okay, and here we have switch 2, and they are connected here. Let's say this is port number Ethernet 1 by 1, or just Ethernet 1 by 1, and this is also Ethernet 1 by 1, and we are using on both switch and switch 2, we are using the, let's say, port channel 1. Okay, port channel 1, and we are using LACP mode active, let's say. Okay, so let's say if there is some problem on this link, so the default timer for LACP is 30-second. Okay, so if there is any issue on switch link, on switch 1 port 1 by 1, so switch 2 is not going to identify or not going to suspend this particular link till 30 seconds. So the default timer of LACP is 30 seconds. So after 30 seconds it is going to know that there is some problem in the link. So that is why now I need to put this port into LACP suspend mode. So just for the sake of the practicals, so I'm just putting the LACP rate fast, so that because when we run this command LACP rate fast, then your LACP timer will be changed from 30 second to 1 second. Okay, so you can use it just in case, let's say you do have some critical server where you want the convergence. So it can be like this, right? Let's say you do also have one more port here into the port channel 1. Let's say here it's Ethernet 1 by 2. So let's say there is some problem in 1 by 1. So for 30 second, if you do not have the LACP rate fast, so the hash that you're using on switch 2 till 30 second, it can send the traffic to this port where it will be dropped, right? So if you do have some critical servers, or maybe you can have any type of requirement that you need the fast convergence of LACP, then there we can use the LACP rate fast command. So in that case, our LACP timer will be changed from 30 second to 1 second. But we need to use this command with caution, because just in case if you we miss something within 1 second for the LACP perspective, then your link can goes into the suspend state. So for just for the sake of practicals, I'm just enabling the LACP rate fast here. Okay. Okay. So now LACP rate fast is enabled, and I will go to interface. Not sorry, no interface port channel 1. It was interface port channel 2. No shutdown. So show run interface port channel 2 membership. So now we do have Ethernet 1 by 3 and 1 by 4 into port channel 2, right? Mode is drunk. So show port channel summary. We can see here that our both the ports are off. Now if I go back to our drawing, so because right now we do not have the VPC, right? Our N7K1 is single connected to the N5K. So now N7K1 and N7K2 do not need to appear as a single device to N5K1, right? Because N5K1 is connected to only N7K1. So in that case, N7K1 is not going to use the VPC system MAC, okay, as a LACP ID. Because if I go to N7K, not N7K5, sorry, not N7K1, but on N5K, if I check show LACP neighbor interface port channel 2, now you can see here it is using 50340A07. And what is that? If I do a show VPC role, 0A07 is the local system MAC, because the VPC system MAC is ending with 01, which is the domain ID number, right? So now because now N7K and N5K is singly connected, that is why the N7K is using its local system MAC. And the other benefit of using LACP is that if someone by mistake did some miswiring, it is also going to help us. For example, let's say we have N7K here, right? N7K1, we have 7K2, and this is 5K, right? Let's say we have connected the interface here, right? Interfaces are 1 by 3, and here we are using 1 by 4. Here also we are using 1 by 3 and 1 by 4. So now we are also forming a port channel, right? Let's say by there are two more ports also on 5K. Let's say now they are connected on N7K2, and they are also put in the same port channel 2. So now, because now they are not a part of VPC, so now N7K2 is going to use its local system MAC as a LACP ID now, because 5K is already receiving N7K1 system MAC, right? So now when the LACP receives a different MAC on the port channel 2, it is going to suspend these ports. We can see it also. If I go to N5K1, and let me see what are the ports. 1 by 5 to 6, say no shutdown, switch port, or let's say keep them shut down, LACP rate fast, and I will say channel group, or let's say switch port mode trunk, channel group 2 mode is active, and now let's no shut the ports. Show an interface for channel 2 membership. Now we have all the 4 ports into port channel. Now let's go to N7K2. So on N7K2 we have ports 5 and 6, which is connected to N5K1. So I will go to N7K2, interface Ethernet 1 by 5 to 6. I'll say no shutdown, switch port mode is trunk, and channel group 2 mode is active. Now if I go to N5K1, if I do a show port channel summary, now you can see the port channel into the port channel summary, port 5 and port 6 are suspended. Why port 5 and port 6 are suspended? Because now LACP finds out that there is a miswiring, and its two ports 5 and 6, they are connected to some different device, because VPC is not formed on the N7K and N7K2 ports, which are going to the N5K1, right? So that is why this is very important that we use LACP, because it is also identify the miswiring for us. So these two ports are not going to come up. So if I do a show, let me try, we can see here, show LACP neighbor interface port channel 2. 546, you can see here, because now on 3 and 4, you can see here the LACP system ID is 0A07, and on 546 it is receiving 0907. And what is the 0907? 0907 is the local uh, local system MAC of N7K2. So that is why, because LACP identifies some problem that it is being miswired, that is why the port 5 and 6 are suspended. Okay, show port channel summary. So now let's create the VPC now. So on N7K1 port number 1 by 3 to 4, and on N7K2 port 1 by 5 by 6, they are part of port channel 2. So now we'll put the port channel 2 into VPC. I will go to N7K1, I will say interface port channel 2. Let's say we will put it into VPC2. So if I do not use any keyword after this VPC and I say enter, so by default it is going to take the number same as the port channel. So the port channel number is 2. So if you enter just after VPC, by default it is going to take the same number. So if I check here, show an interface port channel 2, you can see here by default it took the number 2 because the port channel number is 2. We need to do the same on another side as well. So I will do a interface port channel 2. We need to say VPC. If I do a show run interface port channel 2, show VLAN, I think some VLAN is already there. Show VLAN ID 30. Show run interface port channel 2. Okay, we'll see it later. So show run interface port channel 2. So VPC is created. Let's remove this command first. Maybe it took it from some previous configuration. Okay, show run interface port channel 2. So now our VPC is created, right? Where do I show VPC? So we can see here the VPC number 2 is created and it is into port channel 2 and the status of the VPC is up. So if I go to N5K1 now, if I do a show port channel summary, you can see all the ports are up. And now if we check show LACP neighbor interface port channel 2, now you can see here that on all the ports N7K1 and N7K2 they start using the VPC MAC, right? BE1. Here you can see BE1. What is that? That is the VPC system MAC, because now N7K1 and N7K2 they are presenting themselves as a single switch because now they have created the VPC, right? Now we are using the port channel with VPC number 2. So now BE1, if you check again, show VPC role. So this BE1, that is the VPC system MAC. So this is how we create the VPC. Okay, so one thing that we need to keep in mind is that you can see here the very first bullet is the order must be followed. What does it mean? It means that your VPC member ports are not going to come up unless your VPC peer link is up, and your VPC peer link is not going to come up unless your VPC peer keep alive link is up. And you cannot form a VPC peer keep alive link unless you create the domain ID. Okay, and your domain ID is not going to be configured unless you enable the feature. So you need to keep in mind that this order must be followed. Okay. Also, the logic that we have discussed in the VPC peer link, that is also applied into the VPC member ports also. So you can see here some of the unsupported designs. So you cannot do like that on one switch. You are using the M1 line card, and on the another switch you are using the F1 line card. So this is not supported. The second example is also there. You can see here on one side you're using F1, on the another side we are using F2, so this is also not supported. On the third example, you can see on one side we are using M1 and on the another side we are using M2, so this design is also not supported. So this logic is also same as we discussed in the VPC peer link. So here you can see some supported line card combination for the VPCP member ports. So you can see on the first example on both side we are using the M1 line card, In the second one, we are using the F1 line card on both side to connect to the downstream device. And on the third example, we are using the F2 uh, line cards. So this is how we configure the VPC. So see you in the next section. Thanks for watching.